This webinar focuses to a great extent on the work of my father, Siegfried Zig Engelmann, who, as Brian mentioned, was the senior direct instruction author, the creator of DI. He was a professor of education at the University of Oregon and the founder of NIFTI, the National Institute for Direct Instruction. Among his other very, very unique abilities, he had the uncanny ability to see things from what he called the naive learner's viewpoint, to see where students, where children might have confusion and how to correct that confusion, or even better, prevent that confusion through careful instruction from occurring in the first place. And I love this picture here of him. It was taken in 1970 in Chicago, where you can see he's physically getting on their level, but he really worked hard to see things from the learner's level, whether it's a young learner, remedial learner, any type of learner. He and his colleagues created scripted programs and a comprehensive reform model that NIFTI helps schools implement. But at the heart of it is a teaching methodology that he began way back in the 1960s, which we'll be discussing today. All right, so here are the topics we're going to cover today: origins of authentic DI, where and how did the system of teaching and learning come into being, the development of the critical features of authentic DI, how did DI evolve to become the instructional methodology it is today, a comparison of authentic DI with lowercase di. How are the two types of instructional methodologies similar or dissimilar? Take a trip back with me into the 1960s, early 1960s. I was there, and actually I and my fraternal twin brother Owen were instrumental in my father's first steps in creating his teaching methodology. So my father had a bachelor's degree in philosophy. But after we were born, he started to get very interested in education. He had no formal background in education, yet he developed this systematic, very careful methodology, and he used it to teach Owen and me, and our older brother also, such topics as time telling and mathematics. He wanted to get into education, so he made a film of us as 4-year-olds to show what it is that we learned. The full video is available at our website, nifty.org, under videos, and I'm just going to show a small snippet here. You'll get to see some of Owen in action and some of me in action. That's Owen in the middle and me on the right. So one thing that is unusual about this video is my father wanted to show that there were no shenanigans. There were no extraneous cues or clues that we were getting. So he wrote the problems on clear glass. And as you can see there, we had a tablecloth. He put a tablecloth over us and had our arms showing, just to show that there was nothing literally up our sleeves that was giving us any hints at all, that our performance was simply because of what he taught us using this methodology. One other thing to note is that there is a multiplication table off to the side, and we use it in this segment. We don't use it all the way through. We use it in this segment, although you can see we are starting to memorize some of our multiplication times tables. Here we go. Owen's first.
Okay. Now let's do some real good problems. Okay, Owen first.
Okay. Equals 10L divided by 6. 10L equals 10L is a big number. 6 times sign 5. Count by 6s 5 times to get to 10L.
Good.
6, 12, 18, 20. 24 30. So 10L equals 30.
10L equals 30. Good.
Count by 10 how many times to get to 30. So L equals 3.
L equals 3. Very good, thank you.
I did it without thinking.
Well, that's fine, see? Okay, and Kurt.
Three times 7 equals 63. 3A equals 3A is a heart.
Okay.
63, which is a big number, divided by sign 7. Count by sevens. How many times to get to 63? 7, 14, 21, 28, 35, 42, 49, 63. So 3A equals 9.
3A equals 9.
Count by 3, how many times to get to 9? So A equals 3.
A equals 3. Okay, that concludes it.
All right, so my father took that video of our impressive performance and then went to various research universities, teacher colleges, publishers, to see if they'd be interested in that methodology. And even though it showed that impressive performance, all but Carl Bereiter at the University of Illinois passed on it. So, but Professor Bereiter, he was a professor of education at the University of Illinois, and now he's a professor emeritus at the University of Toronto in Canada. He hired my father on as a research associate to put together the Bereiter Engelmann preschool for highly at-risk students. So these are students who were from low socioeconomic backgrounds. And the question was, could this methodology help their performance? Because the selection criterion for them was that they each had a sibling who was identified as special needs, who was in special ed. So trying to see what would happen with this group using this methodology. Again, there was a video that was taken, and you can access the whole video. I'm just going to show you part of it. Now, this video is of the students as kindergartners after they had been through the preschool for 1 or 2 years with only 20 minutes per day instruction in math from my father. So one thing I should say is that this video does not show an instructional session. It is a playful back and forth. It is just show off. So later on, we'll talk about the actual methodology he used. This just shows the results. And there we go.
That's right. Yeah, you're ending up with 1, so which one's bigger, 9 or B? 9. Which one's smaller? How much smaller? What's one smaller than 9? 8. All right, here you go. I'm getting tired of this stuff. There you go. Good, back. 14 is right. Oh, boy. I can't seem to get you guys very well today. How many minus 11 equal 3? All righty, that's just too easy for you. I can see. What if I gave you just something like this? 10 minus 3. Oh boy, I can't get you on that kind of stuff either. So now, I'll put something in there that, well, watch this.
12!
I thought I'd get you. I thought you'd think it was a plus sign. But you didn't think, what kind of... Yeah, what kind of sign is that? Okay, what if I did something that's much harder than that? What if I did like this? 5 times R equals 20. Yeah, count by 5s. Yeah, whoa, okay, that's good. What if I had it like this? What if I had 5R equals 20? Could I erase the R and put a 4 there now? No, why? Yeah, why couldn't I erase the R there and put a 4? What would it say?
54. We don't want 54.
What do we want to say?
5R.
Yeah, but what do we want to say?
5 times.
5 times 4. So if I erase that R, I also got to put a little bit time sign right in there like that, and away we go.
As you can see from both those clips, my father had as the goal of his methodology, not just catching kids up to performance standards, but seeing just how much their performance could be accelerated. So his approach was really in contrast to some of the developmental stage theories there. Now you saw that those kids and Owen and I were able to problem solve. It's not just rote learning, that we were applying rules and procedures. So the developmental stage theories that were popular then and are popular today have preset norms for what's considered developmentally appropriate. My father's approach was, if students can do it, it's developmentally appropriate. So he wanted to see through careful instruction what they could do, especially if they like doing it, like those kids there in that video. One of my father's first research articles, the citations given here, involved taking 6-year-olds and teaching them concepts like specific gravity, which according to the Piagetian hierarchy was supposed to be too advanced for them. So again, not letting those predetermined norms determine what's developmentally appropriate, but to find out empirically, find out what kids can actually do through careful instruction. Now, even at this point in the 1960s, he formed the core of his teaching methodology, which would persist and does persist all the way to the present day. Even later on, when there are printed programs, scripted programs, programs now that extend all the way up through the secondary level, like Essentials for Algebra and Essentials for Writing, which teaches kids to write in different genres. And so these 5 components we'll see throughout his career. First is to identify and pre-teach prerequisite skills, to do a task analysis and find out what are the pre-skills, if you have this as a goal, then what are the prerequisite skills that students can master, and sometimes break those prerequisite skills down. And then to construct an instructional sequence so that students can go from the more basic, more fundamental to the more advanced. Secondly is to teach students at their skill level with distributed practice. So find out where the kids' skills are in that instructional sequence. If it's more advanced, if they can already do rote counting, then they'll be a little further than kids who don't know how to do rote counting. But teach them at their skill level and have distributed practice so the students can master the material. Thirdly, clearly present examples so there is one interpretation. This is one of the most profound contributions that my father and colleagues have made to the field of education. How to structure the learning environment, how to structure the setup and the examples so students will learn only one interpretation and not learn what the teacher doesn't intend. And next slide, we'll talk a little bit more about this one because it's so key. Fourth is to correct students' misunderstandings and correct them right away, because the longer that students practice something incorrectly, the harder it's going to be to teach them the correct method. And fifthly, reinforce students for their efforts and realize that intrinsic reinforcement is very powerful. And if students are succeeding and they know they're succeeding, that is going to be very motivating to the students. All right, let's drill down a little bit more into number 3, presenting examples clearly. This is sometimes called the single interpretation method, also known as faultless communication. Probably the best way to talk about faultless communication is to show you faulty communication. Show you a presentation where kids can get the wrong idea about what the teacher is trying to communicate. And this example, with some modification, actually comes from my father's 1969 book, Preventing Failure in the Primary Grades. So let's say I am teaching kids and I want to teach kids the concept of porous. I hope my American accent isn't throwing you off. Porous as in permeable. And as a teacher, what I do is I grab this object, this rock, I run my finger over it and I say, this is porous. So that's my presentation. This is porous. Now, as you may know, porous is an attribute, and attributes are not embodied in any one object. And conversely, any object has many different attributes to it. So students can get confused if you're presenting one object, or they can get confused by your presentation if this is a single setup. So what are some of the ways that students could logically misinterpret this presentation? Why, consistent with that presentation, they would look at the other qualities this has. They could think that porous means moving your finger laterally over an object, or that you're talking about something that's brown colored, or it's a type of rock, as well as the intended concept. So this is a really important point, because so much of the time in education, students are effectively being blamed for presentations that are not clear enough and not structured for them to understand, because all of these other possible interpretations are completely illogical. And my father always assumed kids, learners, not just kids, are logical. So really quickly, how can you make this a better presentation? Well, it could be better if I, as a teacher, weren't simply putting my finger back and forth, but the object could be over there, I could be pointing at it, et cetera, to show that it doesn't have anything to do, porous doesn't have anything to do with hand motion. Also, different objects of different sizes, shapes, and colors of porous could be shown, and also showing negative examples to show not porous. So like a steel ball, or even better, if you put over some sort of liquid like glue and say it's not porous now, showing that it's an attribute of that and not associated with a rock. Okay, I hope that's clear or reasonably clear, because we're going to have a poll on faultless or faulty communication. So I'm going to be a teacher again, and you will point out what are some other logical misinterpretations kids could have that are consistent with the presentation I'm going to do. So let's say that students have never seen a pencil before. They're ELL, or they've just never seen a pencil before. And so as the teacher, I'm going to teach them a pencil. And so here I am, I'm holding a pencil, and I tell them, this is a pencil. So what conclusions could students make from this presentation that would be logically consistent with it? Here's what's going to be on the poll that you're about to receive. You get to choose one of these. Right, and the majority of you put in any or all of the above. Yes, with that single presentation, kids could think that pencil means something you hold in your hand, something made out of wood, a cylindrical object, an object with a point on one end, or a writing utensil. So it can be any of those, or any combination of that would be logically consistent with that presentation. Now, how could you improve that? Well, you could show a variety of pencils, like this one that's not cylindrical. I don't know if you can quite see that. You can show that it's not something in your hand. You can show the full range of pencils, such as mechanical pencils, and then show minimally different non-pencils, such as this pen that has ink. All right, that's my attempt at demonstration for the day. But just showing that it's the examples. And interestingly enough, it's not just a lot of examples. I mentioned range, minimal difference, etc. If you want to learn more about faultless communication, this is just a quick test or a quick taste of it. This is the book, Theory of Instruction, Principles and Applications. It's not an easy read, but it has tons of information about faultless communication and the very sophisticated communication theory that undergirds the capital DI, direct instruction approach. And I know that there are teachers in the UK who have discovered this. One of the books, one of the citations I'm going to have that's in the PowerPoint that I'll just show really quickly is Research Ed published a book called Explicit and Direct Instruction through John Catt Bookstore. And I want to give a shout out, I hope he's on the webinar, to Gethin Jones, who's a physics teacher in London, in a chapter in that book, not this one, Theory of Instruction, but the John Catt book that I'll show later. He wrote a very interesting chapter in which he applied this theory to chemical reactions. And he called his chapter Electrolyzing Engelmann. So my father has been immortalized as well as electrolyzed. All right, so, but the important thing about this is this theory can be applied to any body of knowledge all the way up through chemical reactions. Okay, later on, we're going to take a look at Barak Rosenshine's list of effective teaching strategies. What I want to do is throw on the screen here really quickly, not spending very much time at all, on some lists that my father put together in the 1960s. So back in the 1960s, my father was compiling teaching strategies also. This comes from a book that stemmed from that Bereiter Engelmann preschool, which he co-authored with Carl Bereiter, called Teaching Disadvantaged Children in the Preschool. 1966 is when it came out. And we're not going to spend very much time on this because it was like a first draft and things changed quite a bit over time. But there are a couple things in here that appear in contemporary lists, such as number 9, the last one on this list, use questions liberally. We'll see that later on. And okay, the list was actually 18 long. That was the first 9. Here are the next 9. And you'll see number 14, for instance, use lots of examples. So these are both teaching strategies that will appear decades later in different teaching strategies. I do, though, just for fun, want to spend a little time on these last 2, dramatize the use value of learning whenever possible and encourage thinking behavior. So, dramatize the use value of learning whenever possible, number 17 in blue there. What that is, it's actually it's the way in which he set up instruction so that all the tasks seem as though that they are challenging and difficult to do, that only smart kids would be able to do them. So you may have seen some of this in that video clip with the preschool students, basically thinking, this is too hard for you. I don't know if you're gonna be able to do it. Boy, I can't fool you. You guys are getting all these. And so then showing surprise when these kids are successful in doing the material. This is hugely motivating for kids. And you can think of the opposite and how unmotivating the opposite is for kids. So let's say a teacher says that some problem is very easy. Well, that's setting up students for a potential reduction in their self-concept. Because if it's very easy and the kids can't do it, what do they conclude? They conclude that they're less than capable kids. So always making things more of a challenge, recognizing that they're harder, is much better for their self-esteem. And also, this is part of my dad's compassion, seeing things from the kids' point of view, because a lot of things that we think are just dead simple are difficult for kids because it's new to them. Okay, number 18, encourage thinking behavior. Just really quickly, that means reinforcing students who are trying to apply the rules and methods, even if they don't get the answer correctly. So trying to encourage them. So you see from the beginning, the DI approach is very sensitive to kids, very compassionate, very human-oriented, and interested in intellectual development. All right, we've got one other set of these lists. This was my father's list just 3 years later from a book, Preventing Failure in the Primary Grades, what I got that porous example from. And again, we're not going to spend much time on this. You can see there's some things that carry forward, and there are more strategies that appear in contemporary lists of teaching strategies. I do want to spend time just for fun with number 5, don't be afraid of looking bad. So don't be afraid of looking bad. It doesn't have to do with hairdos or how you're dressed or anything of that nature. It's actually an appeal to teachers and coaches or school leaders to keep the teaching going and recognizing that sometimes teaching isn't smooth, that students make mistakes, and that sometimes there are corrections that need to happen when there are errors. So it's an appeal to teachers that no matter who comes through that door to observe you, you do what's best for students, to make sure they get the most out of every instructional session each and every day. And for coaches and school leaders, recognize that if you come in there and there are error corrections, they have to repeat some material. Well, that's part of the teaching and learning process. Okay, so that's in blue, and then in red, you'll see learn to isolate the concepts. And DI is transitioning from small case DI to big DI with the published programs. And when that takes place, there are going to be a lot of things from this list, and this is just the first half of the list, that are no longer going to be necessary for the teachers to do. The published programs will assume those roles, such as learning to isolate the concepts. All the examples will be there. Or here's the rest of the list, and there are various other teaching strategies colored in red that will no longer be something that teachers need to do, such as always seek the simplest form to present a concept, correction procedures, keeping sessions limited to 5 to 8 minutes, etc. But you'll see from that list, there's still plenty to do. So an advantage of having the script, teachers can concentrate on those other things they need to do to make sure that students are successful. All right, so as the 60s, I was going to say wore on, but as the 60s continued, my father was faced with a critical dilemma, and that was how to teach others and how to deliver this methodology. My father, for the most part, put together that instructional sequence, examples, correction procedures, etc., all on the fly, all in his head. He did have a list of examples. Sometimes you can see it in these video clips that he's consulting some examples, but so much of it he's doing on the fly in his head. And he wanted to show others how to do this methodology, so he wasn't the only one doing it. And with some of his colleagues who were very bright folks, it took months. With one of his colleagues, it took almost 5 months of side-by-side coaching, of demonstration and feedback on what examples and what wording, etc. So if anything more than a really small cadre of folks was going to implement this methodology, he had to find some other way of training up teachers. The need for that expanded greatly with Project Follow-Through, which I'm not going to talk about here, except to say that it was the largest educational experiment in the history of the US, and we think in the history of the world. And my father and Wesley Becker, who I'm going to talk about a little bit later, they were the co-PIs for the direct instruction model, which was invited to be part of Project Follow-Through. So all of a sudden, my father and Wes were going to have sites all over the country, and so they needed to figure out how to train up teachers the fast way. The solution, oh, by the way, with Project Follow-Through, there's an article just a little bit more about it. There's an article that came out recently in the Times Educational Supplement, and I wrote a letter that was published. Please read both of those. Project Follow Through demonstrated the efficacy of the DI model for students up through grade 3. And direct instruction scored highest in all measures: reading, language, mathematics, self-esteem, basic skills, and problem solving. All right, so the solution was to get scripts, and when the scripts were around, it greatly facilitated training teachers. How much did it facilitate? Well, this is a quote from Teaching Needy Kids in Our Backwards System, my father's memoir, and I'll just read the blue part here. With scripts, we were able to teach new trainees more in 2 weeks than we had previously been able to teach in more than 4 months. So now teachers could attend a pre-service program training like the ones NIFTY provides on specific programs, and then receive on-site coaching, which NIFTY also provides, and then they would be able to start implementing this program. It still takes a few years to become really proficient in this methodology, even having that training and ongoing coaching. But still, my father was able to get others teachers to implement the model effectively. One thing that's interesting is that my father didn't just wake up and decide to script everything out. He wasn't hit in the head with an apple. Instead, the scripts evolved due to needs in different stages. So at first there were examples, like he started writing examples for himself, examples for the teachers, so they would know what type of objects to say. But teachers still then had difficult with wording, having consistent wording and not saying other things that might confuse the students. And so he decided to script out everything having to do with the presentation. Down to this is a pencil, this is not a pencil for the pen. As you'll see later, we're going to show you some of the scripts. But then teachers still had some trouble correcting errors, and so he wrote out the error correction procedures. And we'll show you one of those error correction procedures later on. So then there was a fully formed scripted program, and most kids and teachers did very well with it, but there were still some students who were struggling. And so number 4 here is, again, one of the major contributions that my father and colleagues have made to the field of education, and that is an extensive field testing and tryout and revision process. So getting students who meet the criteria and trying out the lessons before you use it on a large scale. Getting information about how the kids do with videotapes, audio tapes, student work, analyzing that, rewriting those areas of the program where it doesn't work, trying it out again with other students who meet the entrance criteria, and keep doing that until you have a product that works with the full range of students who meet the entrance criteria for that program. And my father and company were absolutely tenacious in doing this. With Reading Mastery, the main developmental reading program, which was DISTAR reading, the initial sequence they wrote and threw out 3 times before they said that was good enough, and with additional changes too. But the main sequence was just started over because it wasn't working for all the students. How intensive was this? It was intensive. So this is also from his memoir, and I'm going to read the whole thing. This has to do with the revision of corrective reading, which is the main remedial reading program for kids in grades 3 or 4 on up. So he wrote, when all work is finished, we have enough charts to paper a 12-foot wall from ceiling to floor, enough copies of student material to fill 4 standard filing cabinets, and probably more than 2,000 pages of manuscript for each iteration of the program. So that was a lot of work, but the result is, as I said, programs that if they're implemented with fidelity with students who match the placement test criteria, they are universally effective. Really, really awesome programs. Awesome. Now, if I had more time, I'd get on my soapbox and say, shouldn't this be standard? I mean, we have crash dummies for cars. There are all these procedures for the vaccine against COVID-19, et cetera. Shouldn't there be just as rigorous a process for the materials that our students are getting, that our teachers are using before it's published? And I would say yes, but you can see that this is a real barrier, a real added cost, which is one reason why this really hasn't taken off in the field of education. And And such a thorough tryout and revision process is also a barrier to individual teachers doing much more than creating lessons or units rather than a whole program, which we'll talk about a little bit later. Okay, you will get to see scripts later on, but I just want to throw in a poll here and tell you a little bit about the conventions. So across the programs, there were certain conventions that were adopted. Teacher talk appears in blue, as it does here. What the teacher says is in blue. The directions are in parentheses. And the student responses, what the students say or do, are in italics. That's the expected student responses, which can vary, of course, depending on what the task is. So sometimes it will be concrete. There will be a definite answer that's expected. You ask the kids, what's 8 plus 6? It'll appear in italics. The students should be saying 14. But there are also open-ended questions in the DI programs, such as, what do you think is going to be in the picture? What do you think is going to happen in the story tomorrow? Those type of things. And in that case, in italics, there will be the words idea with a colon, and then some thoughts about what is reasonable. Okay, ooh, I hope my internet went okay. I seem to have frozen there. I'll just say that last part. Open-ended questions with idea, and then some reasonable guidelines for the teacher in terms of what should be expected from the kids. All right, so by this time you've memorized these, because here comes the poll. One of these is false. For those of you who pointed out that the incorrect one is the second one, you are correct. Directions to the teacher are in parentheses, not expected student responses, which are in italics. Very good. Okay, keep that in mind. That'll help you when you see the exercises we have to share. It'll make that easier for you. We're transitioning now from small DI to big DI. When the published programs come out there, my dad's methodology is then referred to in caps. But before we do that, I just want to show you that my father did use the term direct instruction, small case, lowercase, to refer to the methodology that he was using. This is from that book that he co-authored with Carl Bereiter about the preschool. And you can see here in blue, the direct instruction approach ensures that so on and so forth. Just throwing that out there so you see that. He was using small DI. But then starting at 1968, that's when you can say that the methodologies was now starting to get referred to in caps. Why? Because the published programs now had a title where DI was in caps, with the publication of the DISTAR programs, DISTAR reading, language, and arithmetic, where there was a couple, 3 levels of each of those. They weren't all published in the 60s, but they started being published in 1968. And DISTAR stood for a couple things, but it's most widely known as Direct Instruction Systems for Teaching and Remediation. No, there won't be a poll on that. But I should say, DISTAR reading and language, over time, parts of those programs have been incorporated into reading mastery, along with other things through various revisions over the years. And DISTAR arithmetic is still available for purchase, as it was published all those many years ago. Okay, here's one of those slides I'm going to go through the fast way, just throw up on the screen. Not throw up on the screen, that sounds terrible. Show on the screen, and you can consult with this later on. These are sources that if you want to construct your own DI explicit lessons, these are sources you can consult. The first is by Anita Archer, and I'm going to talk for just a little bit more to her work later on. I have a copy of that book right here, as a matter of fact. The second one is the Research Ed book that I mentioned. But I want to turn your attention to these 3 sources at the bottom, because all 3 of these had as co-authors or lead authors direct instruction authors of the programs. And so they involve adaptations or extended explanations of the approaches used in the DI programs. So for instance, the first one, the Carnine book, Direct Instruction Reading, it has many of the procedures that appear in that book are derived from reading mastery, language for learning, and corrective reading. So I would recommend those books, even if you're using the printed program. It explains more. It puts it in the context of the other themes in education. So I would recommend all 3 of those, as well as all of them. What the heck? We're all, we're most of us are in confinement, so all we have to do is read, right? Okay, that was for constructing individual lessons. If you wanted to put together a full program, I would also recommend this book, Rubric for Identifying Authentic DI Programs, which was authored by my father and Jeff Colvin. And what they did is they identified seven different levels that programs are constructed. They're constructed these 7 different levels. And each level, there's a set of rules or axioms to make sure that instruction is effective and clear. And there needs to be coordination between these different levels. So what happens on the level of a task has to be compatible with what happens on the level of an exercise, with what happens on the level of a lesson, with what happens on the level of the whole program. So it's a short book, but it's very helpful to have. Okay, so far we've been talking about my father and my father's work, which started in the 60s. And now I want to talk about others who were involved in explicit direct instruction, and then the intersection between these two. And we'll take an emphasis on the list, or we'll put an emphasis on the list created by Barak Rosenshine that many of you have seen and referred to. So Barak Rosenshine was at the University of Illinois also, arrived there in 1971, the year after my father and most of the DI crew, his colleagues there, moved to the University of Oregon, but there were still some very key people who stayed in Urbana-Champaign. So I met Barak Rosenshine when I was 10 or 11 years old. He came over to our house, and my father introduced him as someone who was visiting our sites. So the role that Barak Rosenshine took was as a synthesizer and a compiler. So Anita Archer is someone who has done a lot of hands-on work helping teachers of professional development, where she is modeling, she's coaching, she's going into schools, et cetera, giving feedback and doing webinars. That's in contrast to Barak Rosenshine, who had the very important function. He didn't work directly with schools. He observed classrooms, but instead he compiled effective teaching strategies from different sources, which is a very, very important role. And it's akin to the work of John Hattie with meta-analyses, compiling them and putting them in a form that's accessible and understandable to the rest of us. He drew from the work, so in putting together this list of teaching functions, he drew from the work of Wes Becker, who was the co-founder of the Engelmann Becker Corporation, the company that organizes and supports the work of the DI authors. And it's probably a good idea he didn't consult any of those earlier 60s lists, but he consulted the list in the 1970s, among other sources too. If you're interested in exploring more about the history of capital DI and small DI, there are a couple of sources, a source by my father and one by Barak Rosenshine that you can see. But let's transition now to the 10 principles and how they're manifested. If you take a look here, you'll see that there are different sources that Barak Rosenshine used, and he said they're all compatible, including DISTAR, direct instruction. But I want to point out that in capital DI, there are many other principles, such as those in the theory of instruction, that don't appear on this list. And for more of them too, I'm just going to give a quick plug to this, the Implementer's Bible. This is a very good read, very accessible. It also has some things that are outside of those 10 principles, and I highly recommend this book. Okay, so we're going to go through the Rosenshine's 10 principles, starting with principle number 1, which is begin a lesson with a short review of previous learning, which is a sensible and research-based thing to do. However, in the direct instruction programs, new learning plays, I should say, review plays a much more prominent role in capital DI than it does just in terms of beginning a lesson. So in the DI design, new parts of a lesson account for only 10 to 15% of the total lesson. The rest of it, the remaining 85 to 90%, is review and applications of things that were introduced previously. What does that do? So it means if kids are placed properly at their performance level, if they've mastered the previous lesson, there's only a small increment for them to learn, which is quite manageable. Also, with that 85 to 90%, that promotes fluency, that promotes automaticity in things that were introduced in previous lessons. So that helps build a very strong foundation for those students to learn new material. Who's that most important for? It's important for all learners, but it's really important for those remedial learners who've had a history of struggling. Because if they know that there's just small increment and they come to school every day and they learn this lesson, they learn this new thing that the teacher did, and then the next one and the next one, that really will help not only their performance, but their self-esteem. My father loved to show this graphic. which represented this design element of capital DI, with each step representing a lesson shown by the numbers here. And if students have mastered lesson 5 and they're ready to go on to lesson 6, then this is just the small amount they have to learn before that they're going to learn in lesson 6. And the rest of it is review and applications in lesson 6 that was introduced in lessons 5 and previously. But if they're not placed properly, or they didn't learn all of lesson 5, then what's functionally going to be new to them, they're going to have to learn what they didn't learn in lesson 5 plus the new material. And that if that gap gets too big, they will have difficulty doing that. So we're going to do a poll right now, and only one of these is true with regard to this incremental step design. If you put the second one as being true, that's correct. The first one having to do with the first one with the incremental step design, it does matter where you place the students. Absolutely. If you don't place them on their step, then they won't have that small learning increment. So you want to place them where they're at mastery. And in some of our more advanced trainings, our coaches training, we cover how to go into a classroom at any time and see whether students if this instruction is at their skill level. There are placement tests for the beginning of the programs, but there are also methods. So at any lesson, you can go in and determine whether this instruction matches their skill level. It's true that having so much review promotes automaticity in skills. And then number 3 is also false, because if they don't master everything in the previous lesson, why they've got that 10 to 15% to learn that's new in the new lesson, but also whatever they didn't learn in the last lesson. All right, going on to principle number 2. Present new material in small steps with student practice after each step. Yes, this happens. We just talked about how DI is designed in small learning increments. And so let's give an example of some of these small steps. Research has shown that phonemic awareness skills are very critical as prerequisite skills for reading. So for instance, one of the phonemic skills that's targeted is having the teacher saying words a sound at a time. Man, or rat. And then having kids identify the words. What word? Man or rat. So that's actually a prerequisite skill for reading. But my father and company, through the tryout, found out that there are kids who have trouble with that step. So they put in an even simpler step, which is saying 2 words or saying compound words together. And so in this format, the teacher says words like playground or motor boat, football, and the kids say them fast. Playground, motorboat, football. Not after that much time, after each one of those. So they get practice in taking two words, putting them together, and then that helps them lay the foundation for taking sounds and putting them together. So that's an example of a very important step in the DI programs, after which there are lots of practice. There's a lot of practice. Let me give you another example, and that has to do with carrying and column addition. So as those of you who teach mathematics know, some students have trouble putting the correct numeral in the right spot when they're doing column addition. So this is an example from the addition module of corrective mathematics. So in that module, they start out with a scaffold that gives a very easy step that concentrates just on where you write the correct numeral. So in this exercise, well, this is just an example of the exercise, the authors supplied the answer in the ones column. There it is in the circle. If you sum those up, it equals 25. So the kids already know the answer in the ones column. All they need to do for this task is put the 5 in the correct place in the ones column and carry the 2 and put it in the box. So that appears for a while in the program. Then the circle with the summed amount fades, but the box up top remains. So then kids will compute themselves, know what the ones are, and that box is still there as a scaffold for them. But eventually that's also removed. And eventually they're not just doing 2-digit numbers, but they go up to 4-digit numbers, a variety of digit numbers. And they all are writing the numerals and carrying and putting the correct numerals, whether it's in tens or hundreds or whatever place, doing it correctly because they had this scaffolded practice to begin with. All right, principle number 3, ask a large number of questions and check the responses for all students. We're going to look at a format coming up in which there are questions. For efficiency purposes, choral responses are much better than asking individual turns. If you have a class of 15 kids And you ask all of them. If you do a choral response with 15, you know what 15 kids know. If you ask just one of them, you'll learn just what one kid knows. So what we're going to do is I'm going to show you a clip from a corrective reading comprehension program, level B2. And the comp program teaches kids vocabulary and thinking skills. Corrective reading comes in 2 strands, decoding and comprehension. And this helps with comprehension, hence the name. The number of students in the group is 15, and so the choral responses, as you see, will be 15 times as efficient. So please, in your mind, think, how many responses would there have been if the teacher asked individual turns, and what's the information that the students or the teacher would have received? Here we go.
Moving on. Everybody, name the body system of bones. Get ready?
Skeletal system.
Name the body system of nerves. Get ready?
Nervous system.
Name the body system of muscles. Get ready?
Muscular system.
You guys are doing perfect. Keep going. Name the body system that changes food into fuel. Get ready?
Digestive system.
Name the body.
If we take a look at those choral responses, you should have, there were 4 of them, and you multiply it by 15 students, that comes out to 120 student responses per minute. If there were just individual turns, that would have been 8 individual turns per minute. So you can see a tremendous amount of information that the teacher is getting. And it's very important. All those kids got all the answers correct. But if you're doing choral responses and they're each generating their own, notice they all came in at the same time. There weren't some who were lagging or listening to what the other kids are saying and then copying that. They all were generating their own response. When you do that, you can see if the kids know it or not. And if there's an error, then she would have been able to do an error correction. And as we said before, we want to correct those errors as soon as possible so kids are at mastery on what the different systems in this case are. So the amount of information is far much more, and the amount of engagement is so much more. All those kids were engaged. And if you just ask individual turns, you'll have a tendency for some other kids to space out, I think is the technical question, or technical way in which we refer to that. Also, the teacher could at any time call in subgroups, this half of the group, that half of the group, or individual kids, if she wanted to verify whether they knew the material. All right, we're accelerating through this, and we're going to take these next 3 principles all in one fell swoop. Provide models, guide student practice, and check for student understanding. In the DI design, these 3 steps are referred to as model, lead, and test. Anita Archer, who I referred to before, small DI, explicit instruction, calls it I do, we do, and you do. They're essentially the same things. So I'm going to go through this format, and I'm so lucky to have with me Michelle Davidson, who is a very experienced trainer and coach, and she has agreed to play the part of the teacher, and I'm sorry, the part of the student. I'll be the teacher. Michelle, how are you doing over there? Michelle, how are you? And she's in Toronto, Canada, so hopefully everything's okay there. There you are. Hey, Michelle, how are you doing?
Hi everyone. I'm doing great.
Good, very good. Okay, so we're going to run through this, and please compensate for anything I don't do the right way. Sometimes this cursor just disappears on me, so that'll be the excuse if it doesn't quite work out right. Okay. All right. So she's going to be my student. I'm going to be the teacher. We're running through this. Please follow along. We're going to talk about this picture. Michelle, what is this?
A cat.
Is this a car?
No.
Is this a cat?
Yes.
Is this a dog?
No.
Is this a fish?
No.
What is this?
A cat.
Say the whole thing.
This is a cat.
Is this a fish?
No.
I can say the whole thing. This is not a fish. Listen again. This is not a fish. Say the whole thing with me. This is not a fish. Again, this is not a fish. All by yourself. Say the whole thing.
This is not a fish.
That was really good saying the whole thing. Thank you, Michelle. Okay, so let's analyze this a little bit. Wait, you know what? We're not going to analyze this. It's a poll, and you're going to analyze this for model, lead, and step. So this was just part of the whole exercise. part 1, and these are the steps, A, B, C, D, and E. For each one of these, you're going to get a poll in a second, and you'll determine whether it's a model the teacher showing, lead, the teacher doing with the students, or a test, the students doing on their own. And one of these is tricky. It has more than one of them. Okay, so here are the results. So A is a test. All these items are tests. Not only are they tests, but this shows principle number 1, which is begin a lesson with a short review of previous learning. So this is all material that they've had in previous lessons. And so we're reviewing this to make sure they understand this. B is also a test. And again, making sure they're firm on what was introduced previously before we introduce the new teaching, which takes place in C. So in step C, is this a fish? That is a test. It's the same item. It's one of the questions asked in step A. And then here comes the new learning. Here comes the new 10 to 15%. I can say the whole thing. This is not a fish. So what's new is this negation. Up to this point in the program, the kids have been saying this is a blank. Now they're learning to say this is not a blank, which is one reason why there was that pause and punch that I was doing. And because it's new, there's not just one model, there are 2 models. Then this is a lead, say it with me. And then E is a test. All by yourselves, say the whole thing. And if they had trouble doing this, Michelle, of course, got it right away. Thank you, Michelle. Otherwise, we would have had to go back and do this lead of saying the whole thing. All right, so all these things, just to bring it back to the staircase, all of these things are trying to make sure that kids are at mastery at each and every part of this program before we go on. So it's not just the whole lesson, but each individual task and exercise. Are they at mastery? Will we have a firm foundation to build on for tomorrow? Principle number 7, obtain a high success rate. Well, everything that we've been talking about involves getting a high success rate. So placing students at their skill level is hugely important, and correcting all performance errors, which we've talked about before. So you may have noticed in this format that funny red dot. No, that isn't a typo or anything of that nature. It indicates that there is a written procedure, a written format correction procedure for teachers to follow if students have trouble on that item, not on the previous items. So there's a special format just for that item. For the previous items, which are introduced in past lessons, there was a special format back there that appeared in the book, and it stayed there for a while, and teachers need to memorize those. Those are not carried forward because otherwise you'd open up the page and you have all these formats. So teachers, when you have these correction formats, make sure to practice and get them down, or some people put a sticky note so they know where to go back in case there's some of these more fundamental things that kids are having difficulty with. Let's take a look. We'll take a look at this format, and you'll also analyze it for model leading and testing. So we're going to go through this again. Michelle will be my student. Let's say that she made an error on the last item and she left off not. That's the new part. Kids have been saying this is. Now they're learning to say this is not. And so, so now we go into this format because she made an error on that. Are you ready, Michelle?
I am.
Okay, good. Listen, not a fish. Say it with me.
Not a fish.
Not a fish. This is.
Not a fish.
Say the whole thing.
This is not a fish.
You said the whole thing. Okay, starting over. All right, take just a little over 30 seconds to try to identify the modeling, leading, and testing that's happening in steps 1, 2, and 3 here, and then we will go over that. Here we go. Let's run through these. So step 1, the first part of it is a model, not a fish. And so this actually shows chunking. Whenever there is a long response and kids can't say it, you can do a lead, or you can also break it down into chunks, that's the technical term, and practice those a part at a time. So the first part is a model on that critical part that she had trouble with, not a fish. Then it was, say it with me, a lead on that critical chunk. Step 2 was a model of the rest of that statement, the first chunk, along with a test of that second chunk. This is not a fish. And the last one was a test. Say the whole thing, which you did perfectly. This is not a fish. Now you may see that, you may have heard me say, starting over is what I said. Step 4 says repeat part 1 of the exercise. So when there's an error correction. This isn't the end of it. Now we go back through and we run through the whole exercise again to make sure that the kids are rock solid firm so we can build on that later. All right. Let's go to principle 8, provide scaffolds for difficult tasks. We've been talking about different types of scaffolds with the circled number of 25, scaffolding through error corrections and chunking, scaffolding through leads. But now we're going to just give you one example of scaffolding through prompts. So this is from Reading Mastery Signature Edition Grade 1, near the end of that level. And the students here are reading what's called a mixed set list. So these words are of different types. They don't all, for instance, have E, like easy in them. So if you had a list of easy, leave, if those words were there, then that would be a single type list. But this is mixed with different types of words, which is more challenging for kids to do. To help kids go through this challenging list, the program has them first identify a critical part. So we're not going to go through this whole exercise, but instead what the teacher says is read the underlined part and then read the whole word. E, the kids will read, and then easy, ing, and then ring, and so forth through the list. This not only helps them get through this challenging mixed set list, but it also helps them when they encounter this without the prompts there. They will often know to look at the critical part. And so later on in this program, those prompts are dropped. As a matter of fact, when they encounter these words in the story lesson, they don't have these prompts on them. And speaking of the stories, everything that appears in the stories was already taught. The words were all taught to mastery in word attack, in group instruction, before it appears in the stories. So those stories are completely decodable for the kids. All right, we're moving up now. Principle 9, require and monitor independent practice. So just as there is a really tight coordination between the words that kids learn in group instruction and then what they read in stories, there is a very tight coordination between everything that appears in the DI programs and the independent work. So the objective of teaching kids anything is that they can do it reliably and independently on their own. So everything that is introduced in the DI programs is taught to mastery, and then it appears in independent work. And everything that appears in independent work was already taught to mastery in group work. Because of that, there can be a very high criterion, and there is a very high criterion for independent work. Students must get at least 85% correct on their independent work. If they don't, they fix the errors, so they get practice in the correct answer. And if a quarter or more of the group miss the same item, then it's retaught to the class. This is critical because independent work and scoring is another opportunity for teaching kids what they know so they have a firm foundation for learning other things. Let me just give you an example of independent work, something fairly sophisticated in Connecting Math Concepts, level C, approaching the end of the program there. Story problems. You math teachers must know, I'm sure you do know, that many kids have problems with story problems, that they have difficulty recognizing what operations are being referred to. Translating the wording into equations is very difficult for them. Setting up the equations correctly is difficult for them. And sometimes the computations are difficult for them too. If you look at that box, the kind of rounded edge box there at the end with the 3 different points, that shows what the kids have already learned to mastery during group instruction. So they've already been able to identify the types of operations indicated by different wording. What indicates subtraction, addition, multiplication, etc. They have learned how to set up the problems to work using a number family procedure. And if you look in the upper right here with the line note paper 6A and 6B with the arrows, that helps them set up the number family that then helps them put the equation, write the equation correctly. And then they've learned to compute, so they can calculate and compute the answers correctly. So something that is very complex and challenging for the kids who've been through this program, implemented with fidelity, with enough time and feedback and all those other things that go into the DI program, they're able to do such complicated things as story problems. Now, last but not least, principle number 10, engage students in weekly and monthly review. So they're built-in assessments into the DI programs. The most common of those are mastery tests, which usually appear every 10 lessons or so, but there's variation between the programs. And they concentrate on those aspects of the program, those skills and concepts that were introduced since the last mastery test. Because of all these procedures in group instruction and independent work and giving feedback and repeating until firm, the passing criterion for mastery test is even higher, 90%. And again, students need to fix all errors. And again, if more than a quarter of the students miss an item, it is retaught. Any sort of errors is an opportunity for reteaching kids so they can be 100% firm. That's the goal. There are remedy tables that direct teachers to the specific exercises to use to reteach the concepts that students miss. So here's part of a remedy table for Mastery 1 of the next level up of correcting math concepts. This is level D, and this is the remedy table for the first mastery test. Just the first 5 parts. There are 9 parts in general, but you can see the different parts there. The test items had to do with addition and subtraction facts, number of families, comparison sentences, etc. And in this table, if students, it shows the lesson, the exercise the teacher needs to go back to in the program to reteach what the kids have missed. So if the kids miss addition and subtraction facts, why then the remedy, the teacher goes back and teaches exercise 3 of lesson 3, exercise 1 of lesson 4, exercise 1 of lesson 5. So I know there's a quick introduction to it. Our last poll is this one. Here's a scenario. Let's say that the kids missed, more than a quarter of the kids missed the part in this mastery test having to do with expanded notation. What is the exercise and lesson, the exercise in the lesson that they would not implement? Then you may have noticed what doesn't appear on this chart is lesson 4, exercise 7. So the teacher wouldn't teach that because that's not part of the remedy table here. So this is just an example of a remedy table. And it's there to emphasize the point, again, I've already made a few times, that errors are an opportunity for reteaching kids so they can be successful, so that they can learn the more advanced skills and applications that we want them all to have.